A big plasma wave, perhaps actually multiple plasma waves, are impacting Earth right now. We've seen a shock in the interplanetary magnetic field, a jump in the plasma density, a leap in the velocity of the solar wind. There are more plasma impacts that are soon to follow. We have a transition to a negative polarity high-speed stream coming in on the 22nd, according to NOAA, and that is being preceded by a co-rotating interaction region. We see that coronal hole there emitting that high-speed stream. We also, today at the very end of the 20th, you'll see this plasma filament launch. We'll look at it in the 304 angstrom view so you can really see that. But you see this disturbance basically blast off pretty high velocity right there from effectively Earth center direct, pretty close. And the chronograph imagery actually shows it going this way. So that's also headed our way at this moment in time. And on top of that, we have a huge coronal hole, the biggest yet in solar cycle 25, now rotating into view. Looks like a couple different coronal holes finally merged together. So that is going to be hitting us with a high-speed stream, and that could be quite significant. So we have not only this plasma impact occurring right now and some magnetic field vibrations occurring as a result, but we also have this lineup of solar activity that will be following. So yeah, it looks like we have some longer duration time frames now for geomagnetic activity, probably till about the end of March, considering how long it's going to take this to enter into a geoeffective zone, about a week or so. So as I made a video at the beginning of March Madness, I specifically said after the total lunar eclipse on the 14th, that's when the energy starts to ramp up. That's what we're seeing. And I based that assumption off of a few things. For example, all the different planetary alignments and planetary resonances and Cazimis and more, but also things like the Russell-McFerrin effect. Happy equinox. Today is the equinox. That means that we have greater ionospheric instability right now because you have there be this big transition of light from the southern hemisphere to the northern hemisphere. It's the greatest time of transition for light in terms of radiation on the planet. During the solstice, you will have the greatest disparity, right? The northern hemisphere, for example, during winter solstice won't receive much light. The southern hemisphere will receive a lot of light. But during the equinox, you have this rapid transition. People up in Canada right now, they're going to get like 90 more minutes of light from the beginning of March to the end of March. Meanwhile, people at a similar latitude in the southern hemisphere will lose that much light in their day. So it's this really rapid transition. What does that mean? Well, it is the higher vibrational wavelengths of light that charge Earth's ionosphere. And so that's always coming in. There's more of that coming in during solar maximum. So you already have a stronger ionosphere during solar maximum. That also gets enhanced during things like solar storm impacts. But you also have greater ionospheric instabilities and volatility in general because of that changing light radiation due to how the Earth is orbiting around the sun and its tilt axis in relation to that. So a lot happening right now. I'm going to make another video tomorrow on this coronal hole, but just wanted to clue you in on that because that is the biggest in solar cycle 25 yet. And yeah, we got a lot going on. So what's happening right now is that we are experiencing this coronal mass ejection impact. And as I laid out in my video just a couple days ago, there's a whole range of expressions for this because there were two plasma filaments that launched off, a coronal mass ejection partial halo that launched our way. One of the options was that it would miss, or all of these would miss. Well, it didn't miss. We have an impact right here. We see that very clearly. Our interplanetary magnetic field was very low at only about 3 nanotesla total field strength. And then we see this rapid jump there. I can actually zoom in for you. If we punch in, this is like the past 3 hours or so. We see that increase right there, that quick jump up. And then we see another one right there. And this is the very beginning. Now, one of the possibilities is that this is just the very flank of a coronal mass ejection, the very tip of it. In fact, that may be all we're going to see. That sometimes happens. We see that the interplanetary magnetic field is actually back to the values that it was before. You'll notice though plasma density is still high, velocity is still high, temperature is still high. So often these coronal mass ejections, they kind of have these packets within them, and then they pinch and then they expand again. So I don't think it's likely that this is already over, but that is technically a possibility. What's more likely is that this is just the beginning of something longer in duration. So probably at least 12 hours, perhaps even up to 24 hours. And usually something like a coronal mass ejection will get stronger as it goes on. These sort of coronal mass ejections. So this is just the beginning, kind of the warm up, most likely. And this is probably going to continue to ramp up such that by the time it's morning for me, after I wake up, we'll probably be in a G1 storm, perhaps even G2. That's possible. Depends on the strength of this coronal mass ejection. But we do see this really clear jump in the density right there. So effectively, the amount of ions in interplanetary space increase from 6 to 23, 24 particles per cubic centimeter, and also the velocity jumped up. And it's around 415, whereas before it was 380 or so. So far, not the most significant coronal mass ejection impact, but again, these things take time. We have so many examples that I've covered over the past few months, just over the past few months, of how these things started off slow and all of a sudden we're in a G3 storm or a G2 storm or something like that. We can zoom out just a little bit here to basically show that. If we do our 30-day, we can see these different coronal mass ejections that have come in, and we see this guy, it came in, right? And it took some time for our geomagnetic volatility to increase. Then this one wasn't that significant in terms of the interplanetary magnetic field and some of these other things, but look, we got this long duration of geomagnetic activity. I talked about that. That was a little unusual, but I warned you guys that that was probably the most likely scenario, and lo and behold, that is what happened. So then we had this most recent one right there. We see these increases in the velocity, but we didn't get much of a response, so we'll just have to wait and see how this one goes. But we have already some geomagnetic volatility on the planet. We can look at that with our geospace ground magnetic model, and let's zoom over here to our polar regions, because this is where most of this magnetic flux is occurring. So we have the northern hemisphere, the North Pole, South Pole. You'll see that big push, that initial shock come in, and now you start to see the magnetic field increase in its volatility. Here's our scale. Delta stands for change, and B stands for magnetic field. We're measuring this in nanotesla, so things are quiet and calm and normal. And then you'll see just recently, this is like a 3-hour model that they continuously run. You'll see all of a sudden that impact come in right about there. There it goes, and now we're in that phase. So there is increased geomagnetic activity at this moment in time. We can look a little bit more at that by going to our HB30, HB60 indices, and it's just starting to roll in, so it hasn't been that strong of an impact, but we are seeing how we had quiet conditions. This is a measure of all the different, this is a measure of the magnetic field strength across a wide range of magnetometers spread out across Earth's surface. And then we basically turn this into an index going from 0 to 9, and we can track the swings in Earth's magnetic field strength globally using something like a HB or KP index. So here we see the 30-minute measure, low, quiet, very quiet. That is a pretty telltale sign that you have something coming in too. When the interplanetary magnetic field gets very, very, very quiet and the geomagnetic volatility goes basically right down to 0, then that's often right when you have a coronal mass ejection come in, because there's this void aspect. You have a void in the interplanetary medium in advance of that pile up of plasma that's sweeping by. So yeah, this is just the very beginning. I want to make that clear. This is just the very beginning of this impact, but I wanted to go on just to keep you all aware because I'm about to go to sleep. If I had more time ahead of me, I would wait and then I'd make the video, but you know, there's sleep that needs to be had. So this is going to evolve over the next 8, 10, 12 hours. So just want you to check this out. Again, I'm going to put all these links in the video description so you can monitor this yourself as time progresses on. Now we also have our magnetometer here showing how our magnetotail of Earth's magnetic field is stretching out. Because you have the sun pushing on Earth's magnetic field. And in fact, I can actually pull up this video for you really quick because this is a good video to show you. I've shown it before on the channel, but as I'm talking about it, I should really show you exactly what I'm discussing. So let me just find, this video works as well. Let's do this one. This one might be better actually. Here we have Earth's magnetic field, and this is represented here. And it's actually showing a noteworthy coronal mass ejection impact right there. We see how Earth's magnetic field, this is like a cut cross-section view. It gets compressed here at the magnetopause and extends out with the magnetotail. And so when you get the magnetotail extend out even more, like we get with this coronal mass ejection impact, we'll give this a watch again. Watch how it compresses. When you have that occur, that's when the magnetometer readings that we have drop. So see that? It compresses down like this. That's exactly what's happening right now. If we go back to our data, we see that these values are starting to go down. They will go down for midnight. They just passed through noon. And so they will decline in strength on the dark side of the Earth for a variety of reasons I won't explain now. It's too much. But this rapid drop is because of that squeezing of the magnetotail. And then when you get a magnetic reconnection, you can get this to rebound, and then you can get something like aurora. So let us check our real-time aurora map, because if you are in the United States, and especially Canada, you have a chance of seeing some aurora tonight because of this if you stay up late. Especially even more so like Alaska. Alaska will probably get a pretty good, they've been having great aurora anyways, basically nonstop now. But you can see here our aurora forecast for North America. And so you'll see the pulse really come in right about here and start to sweep through North America. And so that could, see that right there. So it's really starting to widen out at this moment in time. This is yesterday. This is like a 24-hour one. So I can even kind of zoom through this a little faster for you. I'll let me pause it and zoom through. You can see there it's basically pretty minute. And then all of a sudden it really expands right there with that impact. So that's what's happening right now in terms of the aurora for the northern hemisphere. And we can also look at the southern hemisphere. So let's pull that one up. Of course, I don't think anyone is going to be seeing aurora in the southern hemisphere, basically, because it's not going to stretch out unless it gets much bigger. Like, they're not going to see it at this moment in time. But who knows? If this becomes a G2 storm, it's possible. Maybe people southern New Zealand could see it. There are some people in Antarctica. I guess there's some conflict happening in Antarctica. One of the crew members went crazy for South America or South Africa or something. I don't know the full story, but there's so much conflict right now. We pray for peace on this planet. We pray for people to have mental sanity and to treat others with respect. So that's the aurora right now. A little off tangent, but that's the aurora right now. That's the situation. And I have some other data I want to show you. Let's look at what we have coming because we got a lot coming. So we'll go to our 304 angstrom view. Check this out. This is pretty wild. And we'll go here and all we have to do is tap that. Boom, look at that. This is just for the past 24 hours, all right? And so we see at 1800, there's that plasma filament that launched off. That's a 10-degree plasma filament, blasts off from pretty close to Earth center direct, right? Like fast velocity. Not exactly Earth center direct, but I'm pretty sure this is coming our way because of how it appeared on the chronograph. So keep in mind that this is the east side of the sun. If we use the solar coordinate system, which is standard, this is the west side of the sun. We are looking at the sun like this, right? If I'm Earth, I'm looking at the sun like that. So this is east, that is west. This blasted off from close to center direct, but from the east. Now let's look at the chronograph because you'll see that it actually shows up going to the west of the sun. So let's pull that up, and I will have to change my display here to do that. I keep hitting the wrong buttons. Here we go. It's late. That's probably what it is. But I have my duty. I said I'd be an on-call doctor for geophysics, and here I am. So here we have our, actually I should offset this one too. Here we have our chronograph. There is Saturn exiting the scene. We are looking at the sun. This is the circle of the sun right there. And again, this is west, solar coordinate system. This is east. You'll notice right there, this coronal mass ejection launch off to the west. If we pause this and actually zoom in specifically, remember our time, that plasma filament blasts off around 8:30 or so. It was a little bit before that actually, but see that right there? And then we have it going out like this. So if you also look though, so I'll have to use this hand. If you also look though, you'll see that we have a bit of a push actually on all sides in the solar wind. It's not just that. So there is a bit of a shock. Maybe you can see that. I'm sure you can. There's a little bit of a shock that follows out from that. It's really difficult to do both hands here. But that is, I'm pretty sure, from that plasma filament. And because it launched more towards the west, even though it was on the east side of the sun, I think that's likely to hit us. They are modeling that right now. They did not deny in the forecast, they did not deny that that made a CME that's going to miss the Earth. Like that's typically what they'll do. They'll say this solar flare launched a coronal mass ejection, but because of this, and our analysis shows that's going to miss the Earth. Instead, they said modeling in progress, which means it's more likely to hit us than not. When they have that sort of basically language before they've done their proper full analysis. And we also, again, just let us not forget, we got this huge coronal hole that has now appeared on the sun. So this is, again, just for today. And we see it really now starting to show up and really darken quickly too. We see how dark it's getting really fast and also even filling in this area. So what's happening with the coronal hole is the plasma temperature is lower and the magnetic field starts to open up. And as a result, you get all these ions that stream out. They form these high-speed streams. We already have the high-speed stream from this one hitting us at any moment now. That's going to be, well, not any moment now, but that's going to be about the 22nd, according to forecasters, a negative polarity, high-speed stream with a co-rotating interaction region right at the advance of it. Then we have this one to follow. So again, there's a lot in the lineup right now, surprisingly, but there is. And we've had a whole bunch of coronal holes and their high-speed streams sweep by over the past, basically for the month of March. In fact, we've had a ton of tornadoes this March sweeping through the mid-latitude region, specifically North America. And I recently had I guess you could call it a conversation with someone on Twitter X. Basically, I pointed out, hey, you know, I discussed how we had this coronal hole high-speed stream. This is back on like the 14th or so, how that was likely going to enhance any weather systems that were currently in place, specifically that super low pressure system sweeping over North America, more like, again, the southeast, right? That just got rampaged by those tornadoes. And I said it would be good for meteorologists to look at space weather a little bit more often because there are clear connections. And someone called me, you know, some kid who just graduated called me a pseudoscientist saying there was no evidence of connection between solar activity and tornadoes. Well, turns out I did a look on Google Scholar, and there's a ton of research out there linking solar activity, space weather, and tornadoes. And specifically, they show a clear correlation with coronal hole high-speed streams and co-rotating interaction regions with tornado outbreaks about 1 to 3 days later. And that data record is going back as far as we have data for this, and that connection is pretty clear. Now, of course, it's not going to happen every single time, but there is a connection between what we see in terms of weather in the troposphere and solar activity. And the biggest connections are the Hale cycle, which is the 22-year magnetic polarity cycle of the sun. It's also the cycles that are very long, like, for example, solar minimums. We see that has a connection to Earth's climate, reduces the temperatures. Conversely, that would also extend out to maximum periods, bringing in more solar energy, creating higher temperatures. We are in a maximum period right now, by the way. I'm talking like a grand maximum, not just solar maximum. We are in solar maximum as well. And then they also show the one other thing that was identified even back in the 70s as being a pretty clear connection between solar activity and weather are crossings of the heliosphere current sheet. So this is a solar wind. And sometimes the magnetic field of solar winds pointing towards Earth or away from the Earth. And that crossing point is connected to changes in weather. And also with a few of these research papers, tornadoes. And so I only mention that because we've already had a string of tornadoes go through the southeast in early March and also just recently wrapped up. Now we have a new coronal hole high-speed stream with a co-rotating interaction region, a SEER at the front of it, which is like the best correlated thing with tornado outbreaks in mid-latitude regions, whether this is the United States or Australia. And we have this monster coronal hole rotating behind it. So I'll probably make a dedicated video on that, but I wanted to touch in on that because that is something that is at play. And there's so much research on this, but for some reason, there's like this indoctrination that exists between people thinking there's no connection between the sun and weather, which is really wild because if you flip the sun off, you have a switch for that, you're God, you flip the sun off and it turns off, all of a sudden, Earth's going to get really, really cold, right? So I don't understand some of the stuff right now. I think it's just we have so many planetary retrogrades and Jupiter and fall. There's just a lot of stuff happening right now. So I understand it, I suppose. So that's what's happening with the sun. That's what's happening with space weather. We got this solar storm impact. We'll see how that develops. Right now, it is fairly minor, but as we very often see, these solar storm impacts build over time, and the first hour or two isn't that special, but by the time it's hour 6, hour 8, all of a sudden you start to get some increased geomagnetic volatility. And so when I wake up and I check everything, I wouldn't be surprised if we get a G1, G2 storm, or at least just enhanced conditions, KP index 4 or 5, something like that. Though again, it could just be a very minor brush from this coronal mass ejection because it's going more towards the north of the ecliptic plane. But you have to keep in mind that right now it's equinox, we have the Russell-McPherson effect, we have just a greater ability to have a powerful geomagnetic storm because the changes to Earth's magnetic field and the geomagnetically induced currents that result from that, those are all generated mostly in the ionosphere. So you have this thing come in and impact at Earth's magnetic field out at the magnetopause, but it's how you have this ion precipitation down into the ionosphere and the electric currents that generates these magnetic fields that we measure on the surface. And so it's the ionosphere that's more the modulator of the strength of a geomagnetic storm as we experience it on the surface. And right now, because of these factors, equinox, Russell-McPherson effect, equinoctial effect, there's others, that is solar maximum, right? Just the fact that it is solar maximum, that is likely to make geomagnetic storms stronger than this impact would have been, let's say, in June, right? So that's what's happening right now. Hope you found that valuable. If you did, please click that like button, subscribe to the channel. I've been your host, Stefan Burns. I make videos almost daily on what's happening here on Earth energetically. We look at the geophysics, we look at the geology, we also discuss the sun, solar activity, space weather, and more, solar system, planetary resonances, cosmic forces. I bring all that together, and also health and wellness and a bunch of things on my channel. So I know that if you subscribe, you'll learn all this stuff as you go because I make sure to educate people with all my videos. I don't just tell you things. I first and foremost really want you to learn these things yourself so you can do this yourself if you want to, or at least just have a better understanding of the wonderful place that we live in together. So let us, stay sane and keep each other in our, best interests and heart-centered in each other's thoughts, and just make the world a better place each day. With this sort of geomagnetic volatility, there's a little bit of extra energy volatility in general across the planet that can cause a few different health effects. In general, increases metabolism, Some of the symptoms could be, for example, like a headache or increased energy volatility or fatigue, some of these things. So it's important to be mindful of that. We also have some really crazy astronomical geometries and just in general, some powerful astrological transits happening right now through the end of March. So just, keep breathing, make sure you go outside, ground yourself, drink good water, eat good food, keep it simple, stupid, and you will be all right. There's nothing to worry about, but just extend a little bit of grace out to everyone around you and also to yourself first and foremost. So really please take that to heart if you are not. I hope this has helped you, and I will see you all in a future video very soon. Sending you lots of love and light. Again, I've been your host, Stefan Burns. Thank you all so much. See you all very soon.